The EU's Cyber Resilience Act makes software supply chain visibility a mandatory legal obligation. For any manufacturer in the European market, a failure to track your dependencies now carries direct legal liability. To be clear, the developers writing the open-source libraries you rely on are explicitly excluded from this liability. The legal burden stops entirely with the manufacturer, placing the final product on the market. This timeline marks the path to a critical shift in enforcement. By September 2026, vulnerability reporting moves from a voluntary suggestion to a mandatory legal requirement. This leaves the industry split. Enterprise compliance officers are battling tool sprawl, while small and medium enterprises are staring down serious operational overhead without dedicated security staff. Manually auditing spreadsheets or relying on point-in-time attestations is mathematically impossible today. Modern applications rely on thousands of deeply nested third-party dependencies that change almost daily. The only realistic way to support due diligence at scale is through machine-readable, continuously generated evidence. This requires a software bill of materials, the SBOM, and automated software composition analysis. CRA compliance functions as a continuous data integration problem. This reality dictates which open-source tools your engineering team adopts to maintain an accurate real-time inventory. Let's look at the first architectural strategy, embedding lightweight command-line interface tools directly into your existing container build pipelines. In the open-source ecosystem, this category is dominated by Anchor's Sift paired with Gripe and Aqua Security's Trivy. These tools analyze code at compilation. As the code builds into a container image, the scanner intercepts the process to discover every bundled package in library. That analysis instantly generates a standardized software bill of materials in either SPDX or CycloneDX format. The scanner cross-references the freshly generated SBOM against databases like the National Vulnerability Database to find known threats. These scans run in seconds, providing an immediate feedback loop. If flawed, the pipeline rejects the container before the code leaves the developer's machine. For small and medium enterprises, the appeal is primarily financial. As open-source tools, they require zero upfront licensing fees, only the engineering time to wire them into your CI/CD pipeline. But this lightweight approach lacks centralized organizational dashboards. Each pipeline operates in isolation, with no data layer connecting them. This decentralized data leaves compliance officers blind to aggregate, fleet-wide risk. If a massive zero-day vulnerability drops, there is no fast way to see where it exists across the entire company. Syst, Gripe, and Trivy are perfect entry points for startups to hit baseline CRA compliance, but on their own, they are structurally insufficient for enterprise-level audits. The second architectural strategy moves toward a dedicated platform infrastructure. The leading open-source solution here is OWASP Dependency Track. This platform acts as a central nervous system. It automatically ingests the isolated SBOMs generated across every pipeline in the organization. By pooling this data, the platform maps component usage across your entire portfolio, rather than viewing a single application in a vacuum. It introduces VEX, the Vulnerability Exploitability Exchange, allowing the platform to evaluate if a vulnerable component is actually exploitable in your environment. During a crisis, security teams can instantly locate every instance of a compromised dependency fleet-wide with a single query. The trade-off is administrative weight. This platform requires dedicated DevSecOps personnel to host, configure, and maintain the server infrastructure. While it slows down initial rollout, a centralized hub like Dependency Track is a requirement for mid to large enterprises facing strict CRA regulatory scrutiny. Highly regulated environments with zero risk tolerance often look toward a third option, the OSS Review Toolkit, or ORT. ORT is built for policy as code. This involves writing strict compliance rules into the software architecture itself to automate governance. ORT automates complex open-source licensing attribution, preventing legal violations from reaching production. It manages multiple vectors of risk, checking outdated components and modified code, and adherence to internal engineering standards. The trade-off here is extreme complexity. ORT is exceptionally heavyweight, requiring a steep learning curve and a fundamental shift in how developers work. Implementing it requires ongoing alignment between corporate legal teams and engineering leads to define and maintain the rule sets. ORT trades developer velocity for absolute legal certainty. It is a specialized tool for manufacturers where a compliance failure poses an existential threat to the company. To choose the right stack, we map these tools to your architecture. For startups needing developer speed, the lightweight CLI stack is the best starting point. Regulated manufacturers requiring centralized visibility should focus on the platform stack. Attempting to dodge the CRA by maintaining private forks of open-source code will only generate massive, costly technical debt. It is a losing strategy in the new regulatory era. Mature organizations eventually combine these tools, using SIFT to generate SBOMs at the developer level and dependency track to ingest them for enterprise oversight. For an SBOM to be useful in today's landscape, it must function as a dynamic, continuously updated data stream. Treating it as a static PDF generated once a year fails to meet the operational demands of the CRA. True CRA readiness requires selecting the toolset that your engineers will actually use. A security mandate that breaks the CI/CD pipeline will always be bypassed.